Okay, hi folks. Welcome to the presentation. We're running complex network function workloads with Nephio. Quick introduction for those that don't know who we are. My name is Ciaran Johnston. I work for Ericsson. I'm a senior expert in OSS. I work in our network management product development unit based out of Ireland, but we're sort of geographically distributed, obviously. And I've been involved in Nephio now for the best part of a year. So, Stephen?
I'm Stephen. I work for Google as a software engineer. I worked at Nephio for a while. And I guess we can just get started. So for the agenda, these are the basically table of contents. We're going to talk about what Nephio is in 10 seconds, hopefully. And then what kind of workloads are being run right now. And then Ciaran will go into the helm support, why, and then the Ericsson workloads. And I'll go back and come back and talk about the Nephio SDK. So what's Nephio, given that a lot of Nephio contributors are here? So this is actually a slide that we used exactly 2 years ago when we did a pitch. So it's 2 years old slide. Nephio is an automation platform that are honoring Kubernetes-based automations. And then we aim to do 3 swim lanes. The infrastructure that you got to set up your workload, the workloads requirement of the infrastructure, and the workload itself configurations. So far, the talk actually focused a lot more on network functions deployment. And as of today, L2 and also for L3, we only have 2 different vendors, FreeFi-GCs and OpenAir Interface, OAI. They are pretty much doing the same patterns. We define it as a community set of CLDs. Once they get the CLs, they write. We both, FreeFi-GC operators and OAI operators, watch just that CL, that custom resource, and basically does all the deployments, translating the inputs into what is needed for the deployments, then invoke Kubernetes APIs directly to bring up the workload. So this is obviously very hairy by itself, because anytime you have any changes, you have to change the entire operators and then release the full operators. And so for that being the case, that's the reason why we're looking into Helm.
Okay, thanks, Stephen. So I guess the question that was asked about just over a year ago when we started looking at Helm support in Nephio, why do we need to do Helm support in Nephio? I mean, Nephio is kind of transcending the concepts of Helm. It wants to go beyond the limitations that Helm provides, or that Helm sort of introduces and so on. So it was quite a significant question. There were 2 main reasons why certainly I felt that Helm support was important. The first of those would be the ubiquitous nature of Helm. And Helm itself has been around quite a while, so it's quite a mature project. I think it's in version 3, which was released about just over 4 years ago. So it's a very mature and stable and sort of well-used component. I want to say that about 90% of workloads that run on Kubernetes are deployed using Helm. I don't know where I got that number from. I did try and find a source for it, so I have no idea whether I made it up or whether it's real. But certainly there does seem to be a proliferation of Helm charts for simple workloads and more complex workloads. And certainly within Ericsson, Helm is the predominant way in which we deploy the workloads that we build and manage. So it's all over the place. And we do see within CNCF, I mean, there's a lot of different projects out there that are in the space of deploying software and getting things up and running. And Helm is the only one there that is actually at the graduated state within the CNCF community, for what that's worth. The other aspect of the introduction of Helm support is complexity. And there's I think three different vectors that we could consider around the complexity of Helm. Now, Helm itself introduces a lot of complexity. It introduces a lot of imperative aspects, so you can use things like Helm hooks. And if you get very into the Helm ecosystem, it can be quite difficult to sort of bring yourself out of that. So if you get fully bought into Helm, then it can be quite difficult to move away from Helm. So that's one aspect of the complexity. The other aspect of the complexity is actually moving to the KRM model, and the Nephio approach to development isn't quite there yet. It is still pretty complex. It's still quite a challenge for a software developer to sit down and write their operators for their workloads and then to manage those as the workloads evolve over time. So I don't think we've quite solved those problems in terms of onboarding workloads into the Nephio ecosystem quite yet. And the third vector is that even if we have this sort of sunny uplands of the KRM-based Nephio model, and everything's nice and simple and easy, we still need to transition from A to B. So we still need to get all of the existing workloads. We've got quite a large library of workloads from Ericsson and from other vendors that are all based on and deployed using Helm. And we need to be able to support the coexistence of those workloads with KRM-based Nephio workloads in parallel for quite some time to come. So that's the kind of rationale for why we feel it's important to support Helm-type workloads within Nephio. There are a couple of ways in which this support has been implemented. The first one on the left-hand side shows how the Flux Helm release operator can be used to deploy your Helm workloads. In this scenario, we selected Flux because as a kind of a Gitops engine, the Helm release operator in Flux is the only sort of Gitops engine that supports the native use of the Helm client SDK library within it, and therefore supports all of the idiosyncrasies of all of the Helm charts that you might have. So it's a fully native Helm client. A lot of the other engines then will use the templating mechanism to template the Helm charts into KRM and then use the Kubernetes APIs to deploy those, and that takes away things like Helm hooks and so on, which you might be tied into. So what we did in this sort of Flux Helm integration approach was we packaged up the Flux Helm controllers and as a Nephio workload. We can then use Nephio to deploy that into a workload cluster, and then we can subsequently use those custom resources to define those CRDs to define custom resources that describe our Helm workloads, and then deploy those workloads with that Helm release operator. So in that context, we were able to successfully demonstrate the deployment of the free 5G core using the Helm charts that it has into a Kubernetes cluster. And there's a video up on the Nephio wiki which shows how you can do that. The other approach then is the Helm to operator code generation SDK. And this approach takes a Helm chart and runs it through the SDK pipeline, and then generates an operator from that. So you can basically use it as a bootstrap mechanism to get yourself straight into the operator world from a pre-existing Helm chart. And then you can discard the Helm charts and continue to work on with your operator capability. And that obviously brings value because it brings you straight into the Nephio ecosystem, but the downside of that is that you don't get necessarily all of the capabilities of the Helm charts. You might need to do some of your own translation. Okay, so what we've been doing in Ericsson in what we call a sort of technical leadership activity, and I'm just going to hold my hands up here and say I'm not a product manager. I do not make business decisions. I'm an architect, so I take instructions from our business people. So this proof of concept that we're talking about here is purely a proof of concept activity. It's not something that we're sort of commercializing at any point in time at this point. So that said, caveat emptor and all the rest of it. What we've been doing is looking at how we can use Nephio to take an existing Ericsson workload and can we deploy that in different ways, and then hopefully bring those learnings back to the Nephio community and help to steer the direction that Nephio goes in. First goal was to use the Flux and Helm integration work that we showed in the previous slide. So that was pretty successful. That worked okay. We did get a number of learnings from it, and we've written either PRs or tickets in GitHub around those. The second one is a little bit more interesting, and that's the one I'll just show a quick demo of. This is where we built a custom operator, which tries to embed the Helm sort of interactions inside the operator, and it only exposes KRM to the end user. And then the third goal is where we're looking at other opportunities to move beyond Helm. We're looking at sort of the Nephio native approach. Okay, so I'm going to talk a little bit about this goal too. So we took an Ericsson 5G core workload. Specifically, we took three, the NRF, NSSF, and the DNS server. And these are deployed at the minute as a set of cloud-native workloads. They use Helm as the deployment engine. When they're fully deployed, they consist of a number of different microservices. There's databases and communication components, as well as some of the core business logic. And there's three main Helm charts that are used to deploy it. So there's a CRD Helm chart, which deploys some custom resources. There's a service mesh Helm chart, which you can guess what that deploys. And then there's some application logic, which is the core business functionality of the NRF, the NSSF, and the DNS, and so on, which also brings a bunch of other services with it. So what we did was we set up a quick demo environment. The picture on the right-hand side here shows you sort of the end user interacting in the Nephio UI. Under the hood, they're talking to Porch. Porch is pulling in blueprints from the catalog, persisting them as deployments in the Git repo. Config sync is reconciling those into the Kubernetes API server on the workload cluster. And then our operator under the hood is then reading those custom resources and using them to deploy out the Helm charts. We wanted just to get a sort of a skilled developer, but not anybody with particular knowledge of 5G core or Kubernetes or even Nephio. And we wanted to get something that could turn around quite quickly, so a couple of weeks of effort. What we were also aiming to do was some kind of simplified deployment experience, so you only interact with KRM, you're not using values.yaml and so on. So quick video, how are we doing for time? I'll skim through this briefly. I won't walk through the whole video, but we started with one edge cluster. This is the Nephio UI, not quite as nice as the UI from this morning, but it's manageable. And we have our own little package repository for 4 packages, which are both the operator and then the 3 workloads I described. And the first thing we do is we add a deployment where we select the operator to be deployed into the edge cluster. And this is, anybody who uses Nephio will recognize all of this. We had some default parameters that you can populate, and very quickly we go through the propose and the approve flow. And again, within this, nobody's exposed to any Helm. No Helm charts were hurt in the creation of this particular workload. And what we're going to do is, you can see there's the operator is up and running. So now what we're going to do is we're going to just look at the log files that come out of the operator in order to be able to see when the Helm charts actually get deployed. And you can see right now we don't have any Ericsson-specific Helm charts deployed. Then what we do is very quickly run through the deployment of the other packages. I'll show the first one and then I'll skip to the end. So this is the custom resource definitions. It's the same process flow, more or less the same mechanism. We go through, we can see the log files. Eventually we'll spit out the fact that the operator has seen that the workload needs to be deployed and deploys a Helm chart. And then you'll see that we actually have now got a CRD Helm chart actually deployed. We go through the same mechanism. We get the list of CRDs, and they're now deployed in the cluster. And then very quickly we go through and deploy the other 2 workloads. I'm going to move on in the interest of time. But what you'll see when we watch the kubectl command line, you can see that now the service mesh is coming up and running. And you'll see that that was actually triggered by a Helm chart deploy. And hopefully we'll see that once the service mesh is fully up and running in a couple of seconds, that it was deployed using a Helm chart, using the Helm list command. So now we've got 2 Helm charts deployed. And our system administrator, our network engineer, had no idea that they're actually using Helm under the hood. And the third one then is the CCRC package. Again, we go through the same flow, and then eventually we'll show that the operator itself detects that the Helm chart needs to be deployed, and then very quickly you'll see that we fast forward in time, and now quite a large number of microservices are now up and running. These are all deployed using the Helm charts, and we now have 3 Helm charts that have been deployed. Okay, that was the very quick demo. Not entirely sure how to get out of video mode. Let's just see what happens here. Right, so what are our takeaways? So as I said, it was a very quick exercise, a couple of weeks of engineering, write an operator, use Nephio to deploy some workloads using Helm under the hood, an Ericsson workload as opposed to something else. We found that it works. We found it's actually pretty flexible. It gives us quite a lot of freedom to maybe do other things in the operator that we couldn't do with pure Helm charts. But it wasn't something that you can necessarily give to just any old engineer to do. It's not a trivial task, and there are a number of other problems that we haven't solved yet. And it does have a number of trade-offs. It can work well, but it needs care and skill. And for a lot of workloads, we need some kind of an out-of-the-box solution. So we need either something like Flux, or we need some kind of developer SDK which has templating support and so on. And that brings us now over to the second half of the demo, and Stephen's.
illusion of the stairs. So as Ciaran said, we are, as a community, right now we're actively building an Nephio SDK that onboard network functions from network function vendors. The idea is the SDK obviously is a tool that would take in so let's be clear. For L3, we are focusing only on Helm onboarding because, as Ciaran said, 90% of the official number, 90% of network function vendors' workloads are Helm supported already. So we take that Helm chart, take it into the SDKs. It generates 2 packages, one of them for an operator, and the other one's for your workload. And then the idea would be when management cluster doesn't really need to change too much, it does what it's supposed to do. It loads our Nephio CLs plus your vendor extension pieces, and then it watches the Nephio CLs, and then it invokes the business logic, and then it takes out the network functions. And then somewhere you're supposed to send back the status to the runtime. So we have a little runtime that runs right now, well, not right now, but then for L3, we have a little runtime that takes care of the watching of the Nephio CLs, and then it would integrate with the NF business logic, whatever language you write it into. I mean, Go for L3. And for onboarding, the sample that we're going to write is going to, well, the community is going to write, is going to be using the Flux Helm controller, and 35GC is our target workload. So in that particular case, your Helm charts would be sitting on a repo. That information gets conveyed into your business logic, so you can then tell the Helm Flux controllers to pick up the Helm charts from the repo with the business logic translating the inputs into the values.yaml. So that's basically the workflow that would have to happen after SDK generates the packages. I too have a demo, but this is a very crude demo. So this demo basically shows nothing more than the controller runtime running, and I don't even generate a package. I just apply the Nephio CL directly, just to show that it's invoking gRPC in the backend, and it can actually bring up a network functions. It takes some time for it to be clear, but then the idea for this one is you can see we are running Flux Helm controllers already. So I paused the video, which is also kind of weird. And this thing on the real SDK would be part of the package, or the operator package. So that's the dependencies that would actually be created as the workload on the workload cluster. And also, we're responsible for loading all the CLDs into the workload clusters, which is the Helm ones. This is still specific to the vendor. So as a vendor, you have a choice between which particular Helm execution engines that you actually want to use. Again, our sample would be the Flux Helm Flux controller. So now, this is just to show you there's no resource found. Wow, are they in the same? Okay. And this is the Nephio CL, for those who doesn't know. It's just NF deployment. And it has, so this is namespace, and this is the name that we're going to deploy. This is just UPF. And okay. It's basically, in this case, has all the IP addresses set up for the 3 interfaces that we have. So again, because in the real life scenario, we're going to config things and pick it up and apply it to the cluster. For this particular demo, I'm just doing half of the work. So this is just applying the UPF. And once you apply the UPF, this is a video. Yeah, I always forget this is a video. You will see that the proxy controller, which is what this window is looking at the NF deployment and generates a gRPC message, sending out to the other side. And then on the other side, who gets the gRPC message is now taking on the content, which is a direct translation of the NF deployment, basically, and would be generating what needs to be generated. In this case, they're generating the config map that is needed for the Helm, and also so they're showing you this is the config map the second one, UPF-1. That's the name I used. And so this is the config map that's generated based on the NF deployment CL, which is business logic. So this is the business logic you have to write as a vendor. And the second part, which is the extension piece that would come in, that tells you enough information on which Helm repository you're supposed to fetch things, and then what is the Helm charts and which version of the Helm charts do you have. So in that case, you can see that the Helm release is already applied and is in progress. It takes time for this to actually be deployed. I can tell you that. You can see from there, the second part of the message, we generate the Helm released, and those are the fields that are needed to actually create the Helm released message. And then from that point, you are created a UPF. You'll never see the container created because I only have one interface on my VM. So my NAD is pointing to a dummy right now. So this is for those who were in the last ONE Summit, exactly where we were on a workshop for historic reasons. So OK. And just like Ciaran, I have trouble. So OK, so for R3, what is our plan for SDK? The SDK tools itself, which at this point is a Kubernetes wrapper. So it allows you to write your own vendor extension CLDs. It should, hopefully, generate a gRPC server on the back end. So that's the runtime will be able to talk to whoever your back end is. As a packaging tools for your pre-deployment CLDs that's supposed to go in, and your actual deployment CLs would also be bundled into 2 different separate packages that we created. And you can point to a particular gig for you to actually upload. OK, so right now we only have 2 RPC calls, create, updates, and delete. So your gRPC server is supposed to support both of these. And the sample, we're going to deliver a 3.5GC sample. So all the 3.5GC network functions would be merging into a SDK-generated operators and all gRPC server in this case. And then tentative. So one particular community member has promised to provide us with tools that would. So if you notice, for Helm, the primary jobs of a business logic is translating the Nephio CLs and your vendor extension CLs into something that is needed for Helm. Values.yaml plus whatever other repo-related informations. So that business logic, in theory, right now when I wrote the demo that you saw, is the templates and all that Go code that needs to be done. So there are community members within the team that are saying that you can just use a tools that does the mapping, and then we can include that and then run it on the runtime, in which case you don't have to write code as a vendor. So tentative. So hopefully that will be coming. And then other plans that, in terms of more like a POC, now that if we use Helm to do day 1, we may want to do day 2. Day 2 plus is basically the most important thing the operator is supposed to do. So some of the things that we're thinking about, maybe we're using OTel collectors, part of the observability. Maybe we'll export visibility data into the operator. So for those who are interested, the developer summit for Nephio is Thursday and Friday. If you have already paid your $100, it's on the developers and testing forum, which is still here. If you haven't paid, too bad, right? And particularly for an SDK onboarding session, it's 2 p.m. on Thursday. And for the rest of the resources is listed here. So we're good. Thank you. Any questions?
5 minutes, Barney. So.
Go ahead.
Oh, yay. So obviously supporting Helm and Nephio is critical. But in an interesting way, Nephio is a replacement for Helm too, right? So Ciaran and also Stephen, I wonder what are your thoughts on like how things work differently in Helm versus Nephio? Because for both of them, the idea is we start with a generic template and we move towards a specialized, customized deployment version, right? And in Helm, it works as a template, right? So it's very straightforward. It's a Jinja templates written in Python, and you take your YAML KRM and you embed all these little scriptlets and code in it, and you run it through some inputs, and that's your final version, right? Nephio takes a very different approach, probably much more complicated, but much more robust, right? Where you have different controllers coming in and kept functions and doing semantic changes rather than generating YAML and coming with that final version. So maybe this is more a question for Ciaran and Ericsson, like from your internal, invested a lot in using the Helm. You have a lot of experience with that. Comparably, the experience in Nephio, other than the trouble of creating operators, which is a lot, the process itself and that specialization process, how do you feel it's different, and if there are any advantages or disadvantages to each tool?
So, I think it's a big part of this is a temporal issue in that whenever we started doing cloud-native network functions, and Ericsson Helm was the tool that was available. And that's what you used, and it pretty much became like a de facto standard, more or less. And I think it kind of grew capabilities over time as people found limitations and wanted to get more powerful capabilities out of it. And I think part of that, it comes down to everybody ends up using Helm in a particular way. They end up using it in an opinionated fashion according to their workload. So I think that's one of the challenges that we certainly see is that, vendor A differs in the way they use Helm from vendor B for more or less the same patterns, like for configuring IP addresses, network attachments, all of the kind of common things that everybody does. We all do them in opinionated ways with Helm charts. And then the Helm charts themselves are very hard to debug. They're very hard to troubleshoot because of some of that sort of injected scriptlets and so on, and the things like Helm hooks, which people use to kind of solve problems in an imperative fashion. So I think Helm has been extremely useful. We've engineered very deeply into it, certainly in a lot of parts of my organization. I think Nephio is is becoming more Kubernetes native, and I think kind of getting a commonality in the language, so moving towards pure KRM, having sort of syntactically validatable models and so on and so forth. That's all very important to me. But I do think it's going to take some time to get there. I don't know if that fully answers your question, but we're being flagged, so.
3 minutes? There's still a lot of time.
Oh, is it 3 minutes? Okay. That's good. So, but yeah, that's basically, Helm has been around for a while. It's done a great job. Nephio has a lot of hope and promise to be something better, something more robust, something more we can get better interoperability between workloads. But there is still some work, there's quite a lot of work to be done in order to make it fulfill that promise, I think. So, anybody else? You have 3 minutes, apparently. Yeah, Alexei. Yeah.
It might be a little bit controversial question. Are we getting any value out of this, basically embedding Helm into an operator? And I'm thinking about the value an operator typically brings, such as lifecycle management, the ability to be the SRE kind of encoded in the software. So yeah, my question is, what is the main value we're getting out of this? Beside, obviously, benefiting from what exists since the last couple of years from Helm.
So one of the reasons why I proposed that we did this was in order to provide an end user. End users interact with KRM and kept packages for all the workloads they're deploying. So you can have like workloads that are following the pure Nephio approach and then other workloads that are using Helm inside. And from an end user perspective, you don't see the Helm charts. So that was one of the reasons why I thought there was some value for doing that. There is also a potential that if you're building an operator that deploys the workload and uses Helm to do it, you can slowly start to use a strangler pattern to break yourself away from Helm, start taking out the Helm hooks and things like that without needing to necessarily do it all in one go. So it's a kind of a migration mechanism rather than necessarily an end state goal that actually adds value in and of itself, in my mind.
So one of the challenges with Helm is not so much running the Helm chart, but providing it with inputs. That values.yaml file it can be enormous. Sometimes lots of knobs and parameters. Nephio can generate those inputs for you. So I think there's a way of attaching an existing investment. Yeah. Saying it in a different way, but yeah, we're all in agreement here. We're all working together on Nephio anyway. So, yeah, but yeah, that's a huge challenge. You hear from telcos that they get a Helm chart from a network vendor, from an equipment vendor, and it's been validated, it's been tested, but now you have to create the inputs for it, and that ends up being very, very challenging because there's Ta-da!
Agree. Okay, that's time. Thank you very much, folks.